Hi everyone, I hope all of you are doing well. My name is Nelson and I will be teaching mathematics in this video recording. The topic that I will be teaching is the concept of completing the square of a quadratic expression. This particular concept is really common in O-level and IGSCE exams. By the end of this lesson, you will be able to complete the square of any quadratic expression of the form x squared plus 5x minus 2, 2x squared all over 3 minus 5 all over 3x plus 5 all over 4. Alright, so a little bit tip here. If I have here equals to 0, this is no longer a quadratic expression. This is a quadratic equation. So if I take away the equality sign, I have a quadratic expression. Alright, so let's jump into it. So given the quadratic expression ax squared plus bx plus c, where a, b, c are constants and these constants are real numbers. By real numbers there I mean that a, b, and c can actually take a natural number, for instance 1, 2, 3, 4 and so on. It can also be an integer that's either negative 2, negative 3 and so on, or 1, 2, 3 and so on. It can also be rational numbers. In this case, of course, rational numbers are fractions with finite decimals, okay? So it can also take the form of an irrational number. Example 1 all over 3. So in this case, 1 all over 3 has infinite decimals. Okay, another example are all sorts. Okay, so all sorts are irrational numbers. Pi is also an irrational number. So in other words, A, B, C are all elements of the real numbers. Alright, so to complete the square of the expression above, we follow the steps below. Step 1. We factor the coefficient of x squared time. So the coefficient of x squared here is a, so I'm going to factor out a. Of course, we are actually supposed to factor out what is common. In this case, I'm factoring out a, but we do not have a here. So if I'm factoring out a, I have to divide here by a, and I also have to divide here by a. So we will have a, I'm factoring out a, so I'm going to have a below here as the denominator plus c all over a. If I want to recover this expression here, I will simply multiply a. I will have ax squared multiply a here. Of course, this a will cross this a and we will have bx. In this case, we've recovered bx. And if I want to recover c, we multiply a by c. A cancel out a here, so we will be left with c. Alright, so step 2, which is very important, we will add and subtract. Half the coefficient of x and square it. Alright, so we are going to add half the coefficient of x and square it. So we are going to add and subtract. In this case, I have a x squared plus b all over a x, and then plus c all over a. So what we are going to do here is to add half. In this case, permit me to clean here. If you are asked what's half of 5 all over 2, half of 5 all over 2 is half times 5 all over 2, which is 5 all over 4. Now what is the coefficient of x here? The coefficient of x here is positive b all over a. So in this case, the coefficient half of b all over a, half of b all over a is b is 1 over 2 times b all over a, which gives us b all over 2a. And we are told to square it, so I'm going to square it. So I'm going to add and subtract this in this. So I'm going to add and square and also subtract it plus c all over a. So here we have b all over 2a, b all over 2a. Notice this, the sign here is a positive sign and the sign here is the sign here. So what if this place were to be a negative sign? Here would have been a negative sign. In this case it is a positive sign, so here is a positive sign, but we don't always write a positive number. No, a positive sign close to a number. Every number without a negative sign is already a positive number. So I'm going to close the big bracket. Alright, so 1, 2, 3 are called trinomials. So I can write these trinomials as a perfect square. And how will I write that? Pay attention. So what I'm going to do there is a. Now I'm going to group, or rather I can say step 3. I will group like terms. I think it's better that way. I can group like terms. In other words, no, let us not use grouping of like terms. Step 3, I think I should say rewriting the trinomial terms as a perfect square. So 1, 2, 3 are trinomials and they actually have squares. So I'm going to write them like this. So a. So look at this one with square. Look at this one with square. I'm going to write x and then the sign here plus b all over 2a. So this is x plus b all over 2a and then all square. So this is a perfect square for these trinomials. Of course, if you expand this, it will give you the trinomials here. So this is going to be minus, of course, from our understanding of indices, if I have b all over am raised to the power n, this comes in, so I have bn all over an raised to the power of n. So in this case, I will be having b squared all over 4a squared plus c all over a. Of course, 2 raised to the power 2 is 4, a raised to the power 2 is a squared. b raised to power 2 is b squared. So this will now give us a. I can simplify the right hand side here. No, the right term here. So how do I simplify this? Let's see this. If I have 2 over 3 plus 5 over 4, look at this fraction. So if I want to simplify this expression here, instead of me to use the method of finding LCM, I can use the method of equivalent fraction. In this case, I can simply do it this way. I can ask myself, can we make 3 to resemble 4, or can we make 4 to resemble 3? Or we can rather do it like this. Can 4 be divided by 3, or can 3 be divided by 4? The answer is no. So how can I make 3 to resemble 4, or how can I make 4 to resemble 3? What we will simply do here is, I'm going to use this 3 and multiply the right term by 3 over 3, and I'm going to take this 4 here and multiply the left term by 4 over 4. By so doing, I have the denominator exactly the same. So this will give me 8 all over 12 plus 15 all over 12. Because these are the same, you can simply take one of them and 8 plus 15. Alright, so what if you have 2 all over 3 plus 5 all over 9? In this case, can I make 3 to resemble 9, or can I make 9 to resemble 3? So the main question is always, can this be divided by this, or can 3 be divided by 9? The answer is that 9 can be divided by 3. How many times? 3. So if 9 can be divided by 3 times, I'm going to multiply it by 3 all over 3. So this will give us 6 all over 9 plus 5 all over 9. See, the denominators are equivalent. You simply take 1. This becomes what? 6 plus 5 all over 9, which gives us what? 11 all over 9. So I'm going to employ the method of equivalent fraction here. Can I write 4a squared? Can I make a to resemble 4a squared? The answer is yes. Because if you look at it, can 4a squared be divided by a? Yes. 4a squared divided by a. Of course, this is the same thing as 4a times a all over a. This goes, so I'm left with 4a. So I'm going to, so all this is the same as a x plus b all over 2a all square minus b square all over 4a square plus c. So if you divide this by a, you will have what? 4a all over 4a. Right, so permit me to clean the right board. So we will have a x plus b all over 2a all square minus b square plus 4ac all over 4a square all over 4a square. Alright, so this becomes, so since the denominators here are equivalent, we take one of them. So we have x plus b all over 2a all square, and then plus, we take one of them. This becomes 4a square. So I will have negative b square plus 4ac. Of course, I can simply swap here. So if I swap this and this, So this is the same thing as 4ac minus b squared. And if I open up this bracket, I will have a into x plus b all over 2a all square plus a multiplying 4ac minus b square all over 4a. Of course, the final result will be this all square plus, of course, this can cancel one of them, so we will have 4ac minus b squared all over 4a. Alright, so we were asked to complete the square of this. So this is therefore the completed square for the quadratic expression. Alright. Thank you for listening, and I appreciate and I look forward to having questions or comments when it be on this particular topic in